Hi. We mentioned that integration is the opposite of differentiation, and that we're going to look at a way of finding the integral of a function. Okay, so that we could find the area underneath a curve without having to use anything as messy as the trapezoidal method or Monte Carlo method. So I'm going to look at working backwards first of all, because we know that integration and differentiation are opposites of each other, so they'll undo each other. So let's just say that we've got 2x cubed plus c, okay, and we wanted to find the derivative of that. So if we wanted to derive that, okay, 2x cubed becomes, the derivative of that is going to be 6x squared, 3 times 2, and x to the power of 3 minus 1. And c is just a constant, so it's just there to represent any number. And so the derivative of that is just going to be 0. So let's have a look. If this was our original function and we integrated that, okay, we're going to end up with 2x cubed plus c. So let's have a look at how we could write this mathematically. This symbol here tells us to find the integral. So we've got 6x squared dx, and we want to find the integral of that with respect to x. And we know that is going to be 2x cubed plus c, because if we derive that, integration is the opposite. So how can we write this as a rule? So let's say instead of 6 we're going to write a to represent 6, our coefficient of x, and it's going to be x to the power of n. So instead of 2 we're going to write n. So what does this look like in our final solution, in our integral? Our x now becomes to the power of 2 plus 1 is 3, so it becomes the power of n plus 1. Now how does our 2 and 6 relate? 2 is just 6 divided by 3. So it's going to be a divided by a new power of x, which is n plus 1. And this makes sense, okay? Because I know that if I went back this way to find the derivative of that, becomes x to the power of n minus 1, so it becomes 2. So if we're going this way, we need to add the 1 back on. And we go 3 multiplied by 2 to give us 6. So there we go, 6 divided by 3 to give us our 2. Don't forget, we need to put our constant on the end. We don't know what that could be, so we're just going to write c to represent any number. So how does this work with an example? So let's just look at this example. Say we want to find the integral of 2x to the power of 7 dx. So we want to find the integral of that. So let's just apply our rule that we've done here. So I'm going to deal with my x first. So it's going to be x to the power of n plus 1. So 7 plus 1 is 8. I'm still going to have my coefficient out the front, and I'm going to divide it by now my new power of x, divided by 8 plus c. I can write it as 1/4 x to the power of 8 plus c, or I could write it as